A.D.A.P.T is looking at disruptive technologies that are readily available and seeing how we can actually apply them to be able to benefit the warfighter.
So one of the benefits for A.D.A.P.T is to look at both readiness and modernization. How do we fight today's battle and keep our current stuff up and running? What technologies can we bring into those existing systems? As well as how do we modernize the Army for the future battle of future fights?
Quincy is a small company that does power solutions, and we try to take ideas to manufacturing pretty quickly. One of the projects is actually a thermal battery project that's actually part of A.D.A.P.T. Another one we are developing is an energy harvester, which is essentially a micro dynamo. It's a very, very tiny dynamo. And so it reduces the weight for the warfighter. So hence the warfighter doesn't have to carry as much.
So one of the benefits of using the 3D printed buckles, we can 3D print these at point of need to allow for a rapid turnaround time to replace simple items that otherwise would have long lead times.
We're a test group and a system integrator, so we take those devices and figure out how to test them. The one specifically that we've worked on so far was the 40 millimeter wrap antennas. 3D printed wrap antennas to go inside of a 40 millimeter projectile. And so what we did, we took these projectiles, made them operational, and then fired them.
So when in A.D.A.P.T, the beauty of it is we have a university, so very early stage ideas are there. Also, you have a bunch of companies that come with different resources and different expertise.
So NJII for A.D.A.P.T manages the Agile Innovation Management process, where we bring together industry, academia, the customer, which is the Army, to rapidly co-create solutions for the warfighter.
And by having these ideation sessions where you have different groups of experts cross-collaborating and sharing ideas and taking those and running with them, and it's one of those examples where the sum of the pieces are much better than individual parts.
We have flexible antennas. This is an electrically conductive fabric that we can put certain patterns into to do antennas that conform to the shape of the helmet.
We don't necessarily worry about who's going to get credit. We really just have this singular goal of getting a technology developed and put out and implemented.
Every engineer that works at the Department of Defense should spend some time with the guy who's getting the system at the end. It's really kind of gets you focused on, hey, these guys need this capability and the threat's out there now and they need it yesterday.
So these tunnel safing robots are as a result of a real world problem. This issue was coming out of Korea, and we've been able to 3D print these robots, and they become a consumable that we can leave behind so someone doesn't have to go into a tunnel system where you can't see around the turn. So something like this means someone like me doesn't have to go in that tunnel.